Hi guys, welcome back. So we're doing AMC 10A 2022, number 20, which again I believe is not in AMC 12 as far as I know. Nope, it's definitely not. Um, okay. So this one says a four-term sequence is formed by adding each term of a four-term arithmetic sequence of positive integers to the corresponding term of a four-term geometric sequence of positive integers. The first three terms of the resulting four-term sequence are 57, 60, and 91. What is the fourth term of the sequence? So I tried for quite a long time to try to solve this algebraically. The problem with trying to solve this algebraically is that there's four variables because you would have like a plus b equals 57, a and b being the first terms of the arithmetic and geometric sequences respectively, right? Then the next term for the arithmetic would be a plus d. The next term for the geometric would be br equals 60 squared equals 91. Now I did this problem a couple of weeks ago and I somehow was able to solve it algebraically, but then I couldn't replicate it. I know there's some trick. I think the way that I did it originally was I looked at some example sequences of summing arithmetic and geometrics and then looking at the differences, like summing them up and then finding the differences between respective terms and then finding the differences between the differences, et cetera, and looking to see if I could find a pattern. And then in doing so, I was able to solve, I think maybe for R or something. But then when I was working on it last night, I decided to maybe I could just try to find a sequence that meets this requirement. So I tested out many different examples, like 56 plus 1 is 57. Then trying making the geometric sequence multiply by 2. So 58 plus 2 is 60. And then this next term would have to be 4. Then this term would have to be 60, but that only gives you 64. So I tried many different examples. What I found is that the only way it could possibly work is if the arithmetic sequence was decreasing and the geometric sequence was increasing, because the difference to go from 57 to 60 and then 60 to 91, that difference couldn't be made up by the arithmetic sequence. It would have to be made up by the geometric sequence. And the only way I found it to be possible is if the arithmetic sequence was decreasing. So I just tried out example after example. It actually didn't take super long because I started with 56 and then just kind of kept working down. And eventually I found an example that worked. If you do 50 plus 7 is 57. Let me make that 57 better. And then I tried doing double, then I tried triple. So make it 21. So then it'd be 39 plus 21 is 60. So then times 3 would be 63. This is reducing by 11. So now that's 28 plus 63 is 91. It worked. So I finally found one that worked. It took me like maybe 10 or so different examples to try out, which I don't normally encourage trial and error. But in this case, like trying to solve it algebraically was just getting me nowhere. Every time I would like isolate a variable, then plug it in somewhere else, it would just lead into like circular reasoning. So it wasn't getting me anywhere. So then continuing this pattern, minus 11 is 17, times 3 is 189. 17 plus 189 is 206. So again, there is a way to do it algebraically. I was able to figure it out like before, but I lost my work and I can't remember how I did it algebraically. And I just think it's too much work to try to do algebraically. And this is one case where I think maybe just trying to find a sequence that works is maybe the best way to go about it. So it might be a little bit of a time waster, but ultimately not terrible. So, okay. So next time I'll see you for number 21. See you there.